The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello, everyone, and welcome. My name is Nathan, otherwise known as Old Man Bills, and I have Shawn Calderon here. Shawn, how you doing? Sorry, Shawn, your mic is out or something. I can't hear you.
Hey, thank you so much for having me on the show. Can you hear me now? Test, test, test. Oh, no.
There it is. You're good to go. Sorry,
Oh,
pardon me.
okay. All right. Hey, guys, it's great to see you in the chat, and I look forward to sharing with you what's going on in my lab. Nathan, I'm ready when you are.
Yeah, absolutely. Here we go.
Awesome.
You're good to go.
Thank you, sir. Again, welcome, guys. It means a lot that you come and share your ideas in the chat as we go through some of the silly things that I do in my lab. Here I'm starting with a photo of a set of capacitors that are wired in such a way that if you flip one switch, it's 47, 44, depending on what capacitor, nanofarads. And this goes up to 1 microfarad. And what I had done is I put together a little bit of specs and I sent it to Ian, and Ian did his magic because this is beautiful. And so this is going to complement the other cap bank that he sent me. And so I'm going to start including this in future experiments. So I can't thank Ian enough. He's so generous. And so I thought I'd start with this interesting invention. Now, it's worth, I guess, mentioning too that if you try to find a variable capacitor on the internet, you will not be able to find one greater than 1 nanofarad. You just won't. I've Googled and researched it forever. You can get, what they'll say is you'll get 1,000 picofarads, and you're like, oh, that's 1 nanofarad. So now they're really cool looking, these variable capacitors, but there's no variable capacitor on the level of these that Ian makes. And so big thanks to him, and he's brilliant. All right, so I'm going to talk a little bit about electrets. And one of the things about working with static electricity is that moisture is the enemy. In fact, humidity goes up at a certain point. In the literature, it says that a microscopic film of water will form over everything and it will short out your electret, or your electret will leak, is what they call it. So I went to the thrift store, picked up this big, huge crock pot looking heated glass bowl here. And what I'm going to do is I'm going to MacGyver it. This lid here came from one of my wife's pots. The inner pieces came from an old lamp. So I'm just sort of putting this thing together in pieces. And my hope is to keep things dry when I'm working on the electrets. So here I'm soldering with these heat, the coating here on the wires is heat resistant. And so I'm soldering them together and covering them with heat resistant material. What you're seeing here is I'm using alcohol and a toothbrush to take off all of the solder, the resin. Here's the heating element that I'm going to be putting inside of it. And so as I'm building this, this is what's going to keep the inside warm and dry. Let's see here. So these are so what I'm doing is I'm going through my junk wire drawer, and I'm just finding stuff that are heat resistant and cutting them and sizing them, and basically providing enough wire here to start heating up that element with some electricity, AC. Now here we go. I have it all mounted here now. I got the wires soldered. I'm ready to go. So now I'm going to place it in my crock pot going thing here. And yeah, it's starting to look pretty good. Let's see, nice video of my dirty floor. So I'm going to close it up now here and see if I can run a test. I think that's not in this video. Sorry about that. So now I'm going to connect it to the AC of the red Variac up there in the corner. I'm covering, I always take a piece of heat shrink and cover it so that way the wires don't short. It's just a safety precaution. So I can just connect this wire open, doesn't matter. Of course, you don't want to touch any of the wires because it's AC coming from a Variac. It can go all the way up to 120 volts. It's basically touching the outlet. So when I'm working, I usually have layers of protection. So here's one, I have to plug it in. Here's two, I have to plug it in. And then there's a switch to turn on the power here. And then there's a switch to turn on the power. The reason for this is that I want you to really have to think about it, because these Variacs are dangerous, okay? You're basically plugging into the wall and then opening up wires on it and putting it on your desk. So now I've connected it to the Variac and I'm turning it on to see what kind of voltage it needs to heat it up. So there you go. This is 7 volts AC. So this surprises me actually, because I expected it to be using a lot more energy. It's supposed to be a 110 heater, but I put it 7 volts and I only need 350 volts. I'm sorry, 350 degrees Fahrenheit for my experiments. And so about 7 volts does it. I think it's 7. Oh, it's 9 volts. Okay. This is also not very calibrated very well. But very cool. Now I've got that wired. And let's see, is this the right one? No, sorry about that. So my files on the iCloud, they gave me a corrupted zip file. So I had to redo all of my slides here last minute. So here you can see I'm putting down these little Petri dishes, and and I'm going to now place them. And so in those Petri dishes, I'm going to be putting different kinds of plastic, different kinds of dielectric. And then here, I'm going to put it in here. Some of the plastics I'll be using melt at 350 degrees, 320 to 350. So I can actually heat up my plastics in here, keep them perfectly dehydrated, as well as begin running an electric field on the top and the bottom to start charging up these plastics and make them into electrodes. These are some of the materials I'm using. I'm using all kinds of materials. So there's PE, polyethylene, there's PP, polypropylene, and there's some top secret ways to get that stuff. So if you guys are interested, you have my email address, email me. It takes too long to talk about how I get my top secret stuff, but I can at least tell you some of the materials. All right, the infamous pyramid, the Blue Nile. I pulled my hair out this week, and I've been sick a few days, so it's not like I had a whole week, but I could not get the Blue Nile working. This is the entire roll I ordered from Amazon because I got so tired of it. I knew it wouldn't work, but I thought you could show how frustrating I am with this. So all right, so now one of the things that I also did was I wound a bifilar coil my first one. And here I'm going to set it up with the transistor, and I'm going to rig it up to make it into an oscillator. And the cool thing is that it'll oscillate at its resonant frequency. So it's a kind of cool little setup. It's similar to, it seems like, feels like a Slayer exciter circuit friend or sister. It's within that way to have feedback and oscillate. So yeah, these slides are out of order. So here I got it all set up. If you watch the O-scope here in the back, and you'll see there that there's some noise here, but when I take apart this signal, it's actually a ring signal of resonance. So it's just a noisy resonant frequency. Um, One thing to mention too is it's around 300 and something kilohertz. So that's the resonant frequency when I run, and it's just a resistor and a transistor, nothing fancy. But if you look in the middle, that's when you're seeing the primary ring, but you can see the ring moves. This is the ring signal. It's real tough to get it clean because my coil is in bad shape. So here's my coil. I covered it in hot glue. I know it looks like some kind of pastry, but it's about 6,011 turns of 32 gauge wire. Here's exactly how I set it up. Transistor on this little board, a resistor, that's it. And here we see that it's oscillating at 2 to 300 kilohertz range. Here you can see it, 334 kilohertz. So that's the resonant frequency of this pancake. So this setup, I think, with bifilars, if you want to know the resonant frequencies of your bifilar coils, this is the way to go. So this is a coil that I wound. I put on as much 32 gauge wire on this as I could, and I've named this coil Milk and Honey. And so Milk and Honey is going to go through some testing, and then it has a new home, which I'll share with you later. So this was the coils that I had on the rotisserie. That's the silver. There's the Milk and Honey, and there's the Blue Nile. Came out beautifully. But these are the coils I'm going to be working with here to share with you guys how I can get some plasma out of them. Please excuse me for drinking tea. I have a sore throat, so this helps me speak. All right, so what we're seeing here is a normal one of my videos showing you the plasma discharges from one of my coils. This is a standard, basic plasma discharge from my coils. They all look pretty much like this. So if you guys have watched my videos, you're familiar with this. So I wanted to get some good angles of it because what I'm going to do now is I'm going to show you different kinds of coils and see if we can notice the differences in the plasma. So this one is a real, it's consistent. It has this sort of almost like a circle as it shoots off in all directions, maybe almost egg-shaped. And you can just get a sense of how this geometry affects this plasma and what kind of plasma that it discharges. I go a little long on this because when we go to the next ones, I kind of want you to go, oh, wow, yeah, that's very different. Oh, I see that. All right, so that was short stack. Let's see, this is going to be, I think this is Humpy. Yeah, this is Humpy. This is the one that has the 3 different kinds of wire. And what you'll notice is it just blinks. Now I have the same exact setup, same circuit, same everything of the last coil, same voltage and everything. But because there's 3 different gauges of wire in it, look what it does. Now I showed you some of this last week, so forgive me if it's repetitive, but this fascinates me to no end. Why does the plasma look just very different? Why is it blinking? And then the last part, I shared this with you guys last week, so please bear with me. But let's see here. I'll walk you through. Okay, I'm going to go line by line here if I can. Okay, so as I scroll through, you'll notice that that's a DC. If you go here, okay, so I went back one. I'm going forward one, forward one, forward one. And I went from AC, this is the DC output. Then that's an AC, another AC, that's a DC. That's the AC. So you're starting to see the difference. Now, this does not occur in any of my other coils. So this is very unique to this tri-gauge wire coil with the name that my wife hates, Humpy. This was one of the ones that I thought was very strange because it seems like when it flips to DC here, the electrons aren't coming from in the coil, they're coming from the outside. They're coming from the air. You can see right here on the upper left, it is not connected to anything, and it almost looks like you're shooting an arrow into here. So I think this comports with Nathan's theory that it's drawing the energy from the air around it. And so, and we know this if we think about lightning. Lightning will draw the energy from the ground, the earth. In fact, it'll draw so much from the earth that the lightning bolts can actually meet in the middle in the sky. So it's this almost kind of effect, I guess, is that there's energy in the air surrounding it, and this voltage here and the way it's geometry, it's just pulling air from energy from the air around it. And again, it has this sort of marked blinking, which the others don't have. But I do think this one has a cool output. The other outputs, I guess I'm just too used to, where this one is a whole set of new plasma that's fascinating. And of course, you're going to have to watch it for a little bit because we're going to go to the next coil. So to get this kind of in your mind, I feel like this is my favorite output. All right, the next coil, this is going to be my silver coil. I finally was able to get the silver coil working. And so this is wrapped with pure silver, 99.9% silver. And it's roughly 2,000 turns of 33.5 gauge wire. Now this looks very different. The tendrils on this thing are very straight, like swords. I had to solder a wire for the discharge here because the discharge here is very hot. It's hotter than copper, and I don't know why that is. Excuse me. But it would just totally dissolve the silver. And actually now this is a 22 gauge wire that I soldered it to. That's what's pumping out the plasma. And even that is starting to wear away. So that's one new, I guess, difference than the other ones. The other ones don't do this. And of course, the second one is these are some serious swords. There's some serious straight action going. And again, just like the previous two, it's the same voltage, it's the same setup, and same circuit. Now, what I want to do now here is I'm going to pause it because I don't know what it's doing in between, but I feel like these swords are just, let's see here. These swords, these sort of real straight tendrils, there we go. I don't think they're appearing all at once. They're sort of just two swords, and sometimes they'll separate. Then there you go with that one again. So as you walk it through, this is a very different geometry. And I know Nathan is going to probably be able to point this out, but if you can see my arrow here, my mouse, you can almost see the lines that John Bigman pulled out, and Nathan and them talked about it. But you can almost see the lines if you look up real close. I'm going to try to get some better photos of this, but this really exhibited the lines much easier than my other coils.
Hey, Shawn, real quick, go back to that. Just
Okay.
You have a straight bolt of lightning. It looks like pure white going on the right one, going
Right.
straight down, and the tendril follows around the whole thing.
Right. This is unique, isn't it? To this silver is it has a unique plasma display. I guess I could say.
Yeah, it's almost like it's wrapping around it. Sorry, I just had to say that real quick. Go ahead.
No, good observation. Yeah, good observation. While you're on, what do you think of those lines? Can you almost see them?
Yeah. Oh, yeah, this is total different discharge than you usually get.
Yeah, exactly.
Because you have DC spray coming out the sides with
Um,
AC tendrils.
that's what it looks like. It has a lot more the fuzz, I don't know what you call it, than the other plasmas. So that's a good observation. It's definitely surrounded by almost like these DC puffs all around it. Yeah, thank you for that, Nathan.
Oh, you're welcome. Sorry, go ahead.
No worries. So let's see. So of course we're not seeing the little fluffy DC at the bottom, and that's because it only happens on the tri gauge wire coil that I named Pumpy. Let's see here. I just was fascinated with how straight these are. I mean, they're straight. We're so used to the sort of chaotic designs, but the silver here, it has just a whole mind of its own. I thought it would be worth just kind of checking it out. So different. So different. Beautiful. It's art, right? So let's see here. So we'll take a look at it real time for the rest of it. Kind of getting close to it, and like I can with all my other coils. And this one I start adding voltage toward the end. So what you're seeing is I'm bringing it closer and closer to 50 volts. I usually run these about 25, 30 volts input. This was about 40, probably 48 volts was the maximum. What I want to do is kind of show you what it looks like with a lot of power here, but it won't let me. There we go. Right, let's see. So I'm juicing the power here. So let's see what it looks like when I'm adding voltage toward the end. You can see that it's getting really bright. When it gets really bright here at the bottom, that tells you that it's getting more voltage. And then all of a sudden the plasma increases as well. But I always look for this center here because that tells you that's an indicator of the voltage increasing. Yeah, and what's also too, this is a quiet coil. But as I turned it up, it just started acting crazy because look at it, it has bizarre structures. It's just all over the place. I think I'm turning it down now, but when it was up, it was crackling and it sounded like a fire in the fireplace. All right. Um, I'm not sure what I'm doing here. Oh, it's silver coil again. I think this was my first time I tuned it. So pretty much the same stuff. It's going off straight from it. This is a shorter clip. No, it's not. But you guys get the gist of the silver being different. There's what it looks like. I had to put hot glue on the side here because there was a little tiny spot that plasma was coming out. So what I'm showing you here is that in tuning this silver coil, it took me quite a bit of thinking and experimentation because I usually have about 3 different types of copper pipe here, different shapes and designs. And they work with all my coils, even my spheres. But for some reason, the silver didn't like what I was doing. So what I did is I took the bowl shape here and I only gave it 5 turns instead of the 10 turns of my other one. And that's when finally I could get a discharge from the silver. So this is my normal one. If you look at that, that's the one that usually works on everything. That's my smaller stuff. I'm pulling it off there of humpy, but look at how thin and kind of stringy this one is in comparison. So yeah, big difference. So when you're getting into this hobby, don't be afraid to try more turns, less turns. The concave has always been great for me, but you can do the cylinder shape. That works too. Um, I think I keep emphasizing the point. I use hot glue everywhere. I just love it. It comes off real easy, but it holds everything in place when I need it. So I picked up some copper tubing to wind a vortex for the Blue Nile. And I start with just grabbing something that's round. This is a Starbucks cup picked up at the thrift store. But I need something like this to start my winding here. This is a real thick, unruly copper. Drives me crazy. Um, so I'm using gloves. It's not that you're going to get stuck, but I use gloves because they actually help you grip in a way that you actually can handle it. It feels like you have stronger hands when you do it. So this is pretty much, I start with just winding it flat. I make sure it's wound around the size that I want, and not too exciting. It's just keep it flat. And look at that. So I wrap my first winding around the cup's diameter, and now that gives me my start. I should have used a bigger cup now that I have hindsight, but that's what I do. Now you'll see me, I start winding it around the cup just a couple more times to start things off. And there I have a couple turns now, and now I have something to work with. I can now start just loosening it a little bit and making it run on the outside. And this will start the flat. Now you always start with a flat pancake, because once you get the pancake right, then you can make it into a vortex shape real easy. So here you can see that I got the vortex going, and now it's going to be the hard work of Indian wrestling this copper to this is the worst copper to do this with. I recommend 1/8 of an inch diameter, and it has to be copper tubing. Make sure it's copper tubing and not solid. But you notice how I'm just winding it around, and it's going to be sloppy. And so if you perfectionist, you're going to go crazy. But this is the process. I'm doing this because a couple people in the chat over the couple presentations, they mentioned how do you get that vortex shape? So I picked the worst copper tubing in the world to show you how to do it, and and these principles are the same though. You notice how I'm holding it down and turning it, holding it down and turning it, and I got to do it for the whole entire thing. But look at this, it's coming out, it's coming flat. Look at that, almost done. Now, this is a two-handed thing, and if you have smaller copper tubing, it just works brilliantly. When you have this thick stuff, it's just, you're just putting in the muscle. But you can see that it's coming into the pancake shape. So you'll notice I make these little thumb hooks. I do that because it's a better grip than just holding it down. So it's almost done, believe it or not. I'm showing you the tool hooks I work with and flattening it. And instead of it having this cool little vortex that I made, it needs more inductance. So that's why I'm winding twice the number of turns of wire of copper. Now you've noticed in the past that I've used these terminal blocks that are very common in working with circuits, and I'll use them to kind of shape the distance. You notice here it starts with some zip ties, and as you mount it, you'll see that it's starting to make a really nice form. You notice it's starting to turn into a vortex, and this is kind of really it. This is really that's done. These are the cheap white terminal blocks, zip ties, and you're going to get your vortex. All right, so in this video, we're going to go through the steps of how I winded my pancake coil. And so see these rollers? If you take apart those junky old printers that they have at thrift stores, those old inkjets, and the old laser printers, they have these really cool rods. And also too, if you were to go and buy a spool, a wire spool, you'll pay $5-10 for one of these. But if you look for embroidery spools, well, they're the exact same dimensions and same plastic, but these are like $1 each instead of the high price. So this is kind of a way to save money. And if you guys want, excuse me, the link of this, I can find it in my Amazon and give it to Nathan. I think I got 4 of these or 5 of these for $10, something like that. So got a really good deal. And what I'm doing here is I need to take wire from one of my coils and wind it to this coil here. So that way then I have 2 spools of the same wire and I can wind them into that pancake, and that's where I'll get my bifilar. Now here I'm experimenting. I'm gonna put an axle here in the middle and start cutting off the rubber. There we go. It's gonna sit in here, and this was an epic fail. So that's not gonna turn when I want it. So I'm just sharing with you guys a little journey in my lab. So here we go with one of the bars that I might use in rolling these coils. So here I'm using the chuck here to tighten it. And so I'm now going to put it on my little drill here, and this might work. This might give me the wire I need so that way I can make a bifilar. But one of the things I need to do is I want to keep this spindle or this spool on this piece of rubber coated steel that I got from an old printer. And that'll allow me to hand crank and get the wire that I need. These are all stainless steel poles, rods that you can get from old printers, and they are handy everywhere. So it's awesome. Now, one of the ways I like to try to unwind my coils is to just put them on a record player table. These things are so balanced because they're supposed to play music, that they make great spindles holders, and you just minimal effort. This is 36 pounds of 32 gauge wire, and it spins like a hot knife through butter. It's so smooth. And so here I am. I'm cranking the handle here, just making sure everything's working. And I'm watching Nathan's channel. Just chill time with Nathan while I'm winding this. And so the goal is to fill this up with 32 gauge. Then I'll have 2 spools of 32 gauge, and then I can do my bifilar. Now it's a very gentle operation, and what I find out is 36 pounds on this little tiny weak foundation, it's not the best idea. See that here in a second. So what I had to do is I put a steel rod through a milk crate, and then I put a piece of wood here that mounted my drill, and here I am now able to take from the 36 pounds onto this little spool. And so tried many solutions. This one was the best. So there's the acrylic plastic, clear plastic, that are on those old LCD computer monitors. You can get them for $4 or $5 at the thrift store. You get these really thick pieces of acrylic. And so I just cut them, rough cut them into these circles. And what I'm showing you here is this is a silicone can of, let me see, let's do this again here. This is I know I can. Let's see, here we go. Oops. All right, so if you guys want to take a picture of this, what this is it's a release agent. So if you don't want anything sticking to anything, you spray this on it. So if I'm super gluing wire and winding it, and then I want to free my jig from the winding, I'll use this stuff. Now you got to be very careful with this stuff because it's so slick that you'll get it on a little spot on your floor. Let's say it has to be like a hardwood floor, not a rug. And that it'll be a slip spot for a long time. So you got to be real careful. And then my favorite part of this silicone lubricant is if you look on the lower right here, it says does not contain silicone. So yes, this feels like false advertising, but I'm using this to spray on the inside of the discs before I start winding my pancake. There it is again. So you can see my setup. I have 2 pieces of round acrylic, and what I'm going to do is I'm going to set the oh my goodness, the distance between each disc, and that way then that's going to be the distance, the thickness, if you will, of my pancake coil. So here, this washer I'm putting on, that's going to be the depth. So then when I put the other side on, now remember it's slick side stays in the middle. There's no slick side out. The slick side faces in. You notice here I'm hooking it up. I'm putting the clip on here, and this is kind of showing you just how it's going to work. Otherwise, it would have taken a long time to put that wing nut on. So now I'm going to put the wing nut on. It's kind of funny. And I'm sorry, I'm sometimes so ridiculous. All right. Now it's time to set up the wire to go inside the disc. So I put on the wing nut like a wing nut, and then had to take it off because I forgot to put the wire in it. So now I'm taking a piece of 32 gauge wire from the big honkin' coil or spindle, and then the little one that I wound, and I'm meeting them together. Now, I've never done this before. I haven't seen this done before, but in my head, I thought this was going to work. So now you can see that I've taken from both spindles. I'm going to put it through like I should have last time. If you want to know the specs, the holes are 1/4 inch. So I'm using 1/4 inch nuts, 1/4 inch rods. And what I did is found out that having it a 1/4 inch perfectly was going to pinch the wires. And so what I did is I drilled out the hole just a little bit. And then what that allowed me to do is slip it in there without it hurting the wire. And that was it. Awesome. So now I'm going to put the spacer. I'm going to put on slick side in, rough side out. I'm going to get the second piece here. And it's pretty cool. I hope, I hope, I know it worked. But there's some things, the lessons learned here we'll have here in a second. There we go. Now here's where we have it. It's pulling wire from both spindles. And this is sort of a check. Yeah, everything, both of them are taut. Feels good. Nothing bad so far. And it was interesting because it seemed real easy. Everything seemed very balanced. And oh boy, just more hand winding. All right. Okay, so another thing I was doing is I was taking a little bit of super glue and I was just touching it to the wires and then I was rolling it in. Okay. So this was kind of working as something that would bind it together. And because I had that release agent, this this was going to be the technique to keep it sticking together. Now you'll notice here on my nice maple hardwood floors, I didn't put anything down. So thank God my wife didn't see it. So here I put some paper down and I'm just continuing this kind of, so I'll hand crank it and then I'll put a little super glue, hand crank it, super glue. The super glue smell got so bad I had to pull out R2D2, and there you can see him sucking in all the fumes. But look at me, I'm hand cranking it now, and both spools are moving, and I get in the zone. And there you can see it. So one of the flaws you immediately notice is that it's oblong, and it's so bad looking. The reason why it was oblong is because I wasn't ensuring that the wing nut was staying tight. So as I was cranking it, the wing nut came loose, and so what happened is as I was winding it, it wasn't growing, it wasn't increasing in diameter. And I kept hand cranking it. Now, one hand crank was 9 revolutions of the wire. So I was really putting in the wire into this pancake coil and it wasn't growing. And then I looked at the wing nut and it was loose. So the loose wing nut made this sort of kind of 6,000 turns of wire, almost goopy mess. And so I learned a lot, but I wasn't going to give up. Look at that. Had super glue on it, and yet I can pull this off, and because of that silicone, that's not silicone. And so out of order slide, sorry about this. So now, because it was such a mess, I mean, if you touched it, it was just going to spring out into a messy disaster. And you could kind of see the strands kind of going their own ways. And I just thought, you know what? Look at those giant glue sticks. I'm just gonna coat the whole thing in glue. I just don't want to waste all this time I put into this coil. So I'm just gonna go crazy with the glue gun. You can see it. I wasn't planning on it looking like a pastry. It just sort of came out that way. And there it is, a bifilar coil, Shawn Calderon original. Now I marked each wire A and B inside and A and B on the outside. And you know what? It's got inductance, it's got capacitance. It works. Now this is out of order, as you can see, but it shows you how I'm gently threading. Oh my goodness, this is the last slide. So I had a little issue with my slides. Oh boy, I didn't. Earlier I showed it oscillating. Okay, I'm sorry about that. Well, hey, Nathan, this concludes my presentation.
That's awesome. Got a pie.
Oh yeah, I named it Turd Pie. Turd Pie 1.
Turd pie.
Yeah, I'm so, you know, I had just got it oscillating. I should have had that at the end, but I show it oscillating and then I build it. So forgive that.
Well, can you skip back and show it oscillating?
Yeah, let me do that. Yeah, it's pretty interesting. I have the wiring diagram. Let's see here. Yeah, what do you think of the double winding? It worked.
Yeah, it's interesting, man. I've never done it that way.
Yeah, I didn't know. Oh man, did I show it? I showed it oscillating. Way. Let me see if I can look at my phone. I'm sorry here.
No,
Um,
it's okay. It's probably at the beginning.
yeah.
You know, on that right there, Sean. By the way, when you're doing that,
Mm-hmm.
take a cap from a, say, like a Skippy peanut butter cap. You know what I mean? You screw it to
Yeah.
the table, and then all you do is run it around the cap, and it tightens up real quick, real easy.
Oh, would that work with 6,000 turns wire?
No, but it would work with that big thick wire, that other stuff.
Yeah, when
Oh,
I
there you go. I think that's the
yeah,
frequency right there.
here we go. This is the setup. So let me okay. So what I have here, let me go a little bit more here. So you can see the resistor here. Let me make it big. So what you're having here is we have a resistor here that applies a current on the base of this transistor, which see here. So I put a transistor here on this little board, and base is 1, collectors 2, and emitters 3. I color coded the wires. So this red wire goes to the base
Hmm.
from this resistor side. And I have a 6-volt power supply. And so the way it's rigged is that there's a voltage that is switched on and off based upon the capacitance and the inductance of the pancake coil. And what it does is then it resonates at the frequency of the pancake coil, which is 334 kilohertz.
Hmm.
So a simple transistor, a simple resistor, and I was able to get this to oscillate at its resonant frequency. And I'll tell you what, I did some experiments with this coil, and I'll tell you what, there's a lot going on that I've not seen before. Let me
Hmm.
go back to it. There's a lot going on here. And what I mean is, I'll measure, because, there's 2 wires, okay, in this winding,
Hmm.
and A connected to A and B connected to B gives a different inductance if then you change it, and
Hmm.
then you'll get a different inductance. And then as you start changing the configuration, you get different capacitances as well. And I think this is up to 234 microfarads of capacitance. So that's a
Wow.
pretty decent capacitor. And then when I go to the inductance is lousy. For 6,000 turns of wire, I would expect 6, 700, 800 millihenries. I don't think this is even 150 millihenries. So I've got all this copper going on, but I don't have a lot of inductance. And the reason for that is because when electricity goes through one wire, and a magnetic field has an equal and opposite opposing to itself. And then when the other wire is doing it in the opposite, they cancel each other out. That was probably a poor explanation. But basically, when you have electricity going through one wire and another one's right next to it, it basically takes out the magnetic field. And so if you have something that's not, that's getting rid of the magnetic field, well, inductance is the storage of a magnetic field. So because you have this sort of action here with the 2 wires, it cannot store as much magnetic energy as if it was just one wire in 6,000 turns. But the
Hmm.
cool thing is, in my next experiments, I'm going to use this as a capacitor. I read that Tesla used these as capacitors because these were more stable, and capacitors were unreliable in the 1800s.
Hmm.
The second thing, I'm going to use it as an inductor. I'm also going to nail down how to really tighten up the circuit to make it into finding oscillator. I'm sorry, find the resonant frequency by turning it into an oscillator. Because I believe if you can have these pancake coils at certain resonant frequencies and working together, similar to what Nathan's doing, building these coils with the similar resonant frequencies, and see if there are some opportunities for some wireless energy. Not clean, but it is a resonant ring at roughly 300 and something kilohertz. That's all I got, Nathan, for this.
All right, Shawn, I want to show you something because I think it's relevant to what you're doing here.
Okay.
And this is from Nagrez Coils.
Mm-hmm.
And he's also got a pancake coil.
Mm-hmm.
But you watch the signal when it comes to the oscilloscope.
Good morning, Internet. I've got a new pancake coil. Around a slightly bigger, more powerful pancake coil. I changed the transistor with new resistors and new capacitors so I can get better switching. I'm going to still use the golden wine bottle coil on top of the pancake coil. Like that. I'm still going to use my adjustable capacitor here. And I'm still going to connect two useless pieces of copper pipe to the two rods at the top. And then just to make sure that everybody
Look at that circuit.
That's cool.
I'm putting on the oscilloscope. This little red one there is connected to the oscilloscope, this one, and also connected at the top. Those two aluminum rods sticking down inside this wine bottle. This wine bottle is wound with speaker wire. They call it, I don't know, they call it low fidelity speaker wire. I don't know what that means. In the olden days, it used to mean it's supposed to have low resistance to give you better sound quality. Any case, so that is the oscilloscope, and I will connect up power.
Oh yeah.
The power going.
That's a clean ring signal right
Now,
there.
the yellow trace that you see bouncing up and down.
Okay, so real quick, Shawn. Your pyramid coil. Simply set it on top of your bifilar coil.
Oh wow, I didn't think about that.
So he's kind of using the same kind of circuit that you are on your bifilar there.
Right.
And then he's ringing it, and then ringing the his wine bottle, which would be your pyramid coil.
Right. Just taking notes here.
But you can see he's getting a clean ring out of it, and he did a beautiful job winding everything.
Oh my goodness, the wire is as thick as his finger. It better be easy to wind. Try 32 gauge.
Oh, yeah, I don't think anybody's as crazy as you trying that, Shawn. Most people just do it with speaker wire.
If I didn't have that wacky wing nut, I would have had a really clean bifilar instead of the turd pie.
Well, I wanted to show you this basically that I'll drop his link in the description for everybody, but it's just a different way of looking at it and ringing a secondary coil.
Yeah, exactly. And it's a bifilar, which is the fascinates me. Because I wouldn't have expected that. I wouldn't expect so many turns of wire to I do plan also having it to power wirelessly. It's another thing I'm looking into. Um, but it's a rough design. This is beautiful. If I had that ring signal, I'd cry because that's clean.
Yeah, it's. Let me get a good shot of it right there.
Yeah, there you go. Nice. There's
Yep, but it looks like, just so we know, the bottom one looks like it's coil and it pulses and then puts a ring into the top one, which I would imagine, if I'm not mistaken, is his wine bottle.
yeah, the bottom is the primary.
But
Just
think, I
just
mean, think
ring
about it.
ringing it. Hmm.
It's not much different than a Tesla coil when you put the number one winding on the outside. You're basically sending a pulse wave into it, and then
Right.
you're getting it to ring, right?
Yep.
So it looks like the same thing.
It does. It's so clean too. I mean, you look at his desk. I mean, this is the only clean thing on his desk, and it's amazing.
Yeah,
So
it's big shout out to Nate Reyes Coil, man. He's got a whole bunch of this stuff on there, Sean. I'll send you the link to your
thank you.
Facebook.
That's cool. Thank you so much. It's a good idea too. I'll play with that. Um, so lots of kindness in the chat here.
Yeah, answer some questions, man. You had a couple. There was one. It was an input voltage he was looking for on one of your coils. I want to say it was an AC coil you showed in the beginning.
So all of my coils, I power them with a DC and an AC. So I'll put in a 12 volts DC onto the gates of the MOSFETs. Now, because no two MOSFETs are perfectly identical, when I hit with the 12 volts DC, one transistor turns off, a MOSFET turns off, the other MOSFET turns on. And
Okay.
then because there's a capacitor and an inductor or a coil, then that initiates the oscillations at the resonant frequency of the capacitor and the coil, which you could calculate. And so that oscillation starts. It's just oscillating now. Then the second thing I do is I add the AC, and I add the AC with a diode. And so AC with the diode means it's going to filter out the negative side of the AC sine wave. So you only get the positive hump, if you will, of the sine wave. I call it a positive pulse. That positive pulse hits the coils and it causes it to shoot out those long, spiky tendrils. So that pulse is linked to the shape of the plasma. Now the AC, I can go as high as 50 volts, but I usually when I'm showing people, it's usually 15 to 25 volts. It's in that range, and it can go as high as 8 amps. Um, that's a lot of amps for 25 30 volts. But yeah, that's what you're getting as on the input. Those are the inputs. I know it sounds complicated, but I'm going to go over. So my slides got corrupted because I was going to show you how to build a Z coil. I was going to show you in depth on how to get your ZVS working, and those flew away somewhere. So Lord willing, we'll dig into how to set up an indestructible ZVS, and that's what's key. I only use one ZVS now, one, and it does everything. And you can beat it all day, and one MOSFET will go out, but you just unscrew 3 screws, pop a new one in.
Nice.
Yeah, it's nice because it's always dependable. When you buy the boards, ZVS boards from Amazon, they have a lifespan. They just Oh, if you get them lasted for a few months, then your stuff is really tuned. But if you're just experimenting, then you're gonna have ZBSs expire, and you're gonna pull your hair out and throw them
Got a
in
whole box of them, Sean.
the box of shame, is what I call
Yes.
it. In the box of shame. So I'll detail that, and that way you guys can build it, because you just need some 1/8 inch copper tubing.
Hmm.
And this design is where all the components aren't soldered. You just pull them out, swap them in, and runs all day. So that'll be for next week.
Okay.
Next presentation.
Real quick, you got AC and DC at the same time. So I believe that's in your board, right? That they take both inputs and then you can switch them. Is that the board you're talking about using all the time?
So I don't switch them. I just turn on DC in a certain place, and then I turn on the AC in another place. So the DC is only for oscillating. The AC is to take those oscillations and magnify them. So a ZBS is a frequency magnifier. It's an oscillation magnifier. If you put in the AC that I put in with the diode, 20 volts, the outside voltage of the ZBS will be 600 volts, 700 volts. I've seen it as high as 800 volts. So it had amplified the frequency 20 volts to 800 volts. Now that 800 volts is in coil 1, it's in the primary. And that slams a big electric field into the secondary coil, coil 2. And that's where we get now those sparks coming out really big. So I don't know if that answers the question. What do you think?
I think you got to show the board next time you present. I think they're looking for a more of a, hey, where does the input go? You know what I mean? On the board itself. I could be wrong.
I have the diagram. If you want to talk for a minute, or we can talk here, I'll find it right now.
Oh, okay.
Yeah.
You know, I was gonna say for that bifilar on the bottom, when he pulses it, what's interesting is it's acting just like the Slayer exciter circuit with the 47K ohm resistor in it, because it holds back and then lets it all out at one time, and holds back and lets it all out, right? So it's doing that same thing, and that goes right up to your number 2 coil and then hits it the same way to make the ring. So that thing is wireless in itself, in the way it oscillates. You know what I mean? It operates between the bifilar and then the top wine bottle. So that's so interesting in the way he does it, because it gives you hope for other things that you're trying to do that with, right?
Yeah.
So if I wanted to start, say, my rodent coil, and I set it on top of my bifilar now, all I have to do is pulse it. Then I probably get out of my oscilloscope a whole amazing, you know what I mean, different ring out of it.
Right. Yeah. Fascinating. That makes sense. I pulled something up, but I don't know if it's gonna confuse more. I know what I have. I simplified this, and I need to give credit to Charlie C, because he was my proofreader. Here we go. I have it right here. I'm going to share real quick.
Yep.
Let's see here. This is the exact. I made it as simple as possible. As simple as possible. Here we go. Let me know when you can see it, Nathan.
Yeah, we got it.
Yeah, that's it right there. What was important for me in this diagram is to have the real components. So you can slap them on the table. I didn't want a fancy schematic. So this means I lay my components on the table. It's 10. And then all of a sudden, I just start connecting them. You can solder them. I use a little copper pipe. But this is it. This is hours and hours on the ZBS. trying to get it to be perfect. And this is the perfect ZVS. You add the 12 volts right here in the middle, and then out here you add the 0 to 50 volts AC. So DC in the middle, AC. And you can see how simple it is. It's not hard. I stripped ZVS to its smallest, most simplest core, and it works. All that plasma you saw came from this circuit. All my plasma experiments come from this circuit. So this is like the one circuit to rule them all. It is it. So I can put this in. How can I send you this? Can I send it to you in Messenger and you can post it here, or
Yeah,
do you want it?
I'll post it on the community page for everybody.
So do you want me to just send it to you after this?
So yeah, send it to my Facebook and I'll put it up for you.
Okay, will do. I hope that was simpler.
Yeah. Well, yeah, because everybody wants to know how to connect it to make everything work properly. So yes.
Yeah. And the thing about it too, you can put an E-capacitor and coil on it, and then just hook up your oscope, and you'll be playing with resonance, because it will resonate to the capacitor and the inductor. In fact, I wanted to show this. I'll show this real quick. Let's see. You can find it. There we go. Right here. There's this lady, I think she's an electrical engineer. She designed this awesome tool. So how do I share it? I'm presenting it. Do you have to let me share it? Or do I have
Yeah,
to
but I don't see it popping down on the bottom yet.
I see. Okay, I'll do this. Is that working? There we go. Wish I could make it. Let me see if I can make it bigger. Does that look a lot bigger? Can you see it, Nathan?
Barely. I don't know that anybody else can really see it.
Oh man. Okay. What I was just going to show is that you have one, if you want to put in your capacitance, and then you put your inductance, and it gives you your resonant frequency, 22 megahertz here.
Wow.
Instead of using the calculator, you can put.
There it goes. Now we can see it.
Oh, so you see I put 7 microfarads, 7 microhenries, and it gave you 22.7364 megahertz. Resonant frequency calculator tells you how to use your ZVS. If I have a capacitor and a coil I measure the coil with the LCR meter, if you remember, and then it'll spit out the frequency, or using this calculator, or you can put the capacitor and the inductor on your ZVS, and then it'll tell you the resonant frequency. And the cool thing too is that, let's say you have a desired resonant frequency. What if I want 300 kilohertz and my coil 1 is only 7 microhenries? If you put these two in, it'll tell you what capacitor you need. So you can fiddle around with this with whatever resonant frequency you want. Just measure your coil 1 and boom, it'll tell you the capacitor. And then you just hook it up into your ZVS and you're set.
Nice.
Is that sort of making sense?
Yeah. Oh, it makes perfect sense.
Awesome.
We just real quick give a shout out to Dennis here. He built your little cable for your AC and got some 4-inch spikes out of his Tesla coil.
Oh, congratulations. Awesome.
Very cool.
Yeah.
Love it when people have success on these things.
Yeah, that's amazing. That's so cool. I hope everyone who wants to build one feels empowered to build one. And I'll dig in a little bit more deeper with the steps that I wanted to do today. I was going to also teach how to rotisserie epoxy things.
Mm.
So sorry about that. Next week. And all right, let's see some questions here. Let's see.
Yeah, if you don't mind, can I play a video, Shawn, and you tell me what you think?
Yeah, sounds good.
All right. Share screen. So I'm working on my gravity flyer project, and I wanted to show this. And real quick, this is just my ultrasound machine. What's called an ultrasound, but what it really is it's a jewel thief circuit. And you can see the toroid in the center.
Yeah.
And so basically, all it does is it saturates. And when it saturates, it sets off a ring to it.
Mm-hmm.
And on both sides of the saturation level, there's a small ring to each side. And then you got to set it. So I forgot that I did this, and I was using my Slayer exciter here to set it up.
Hmm.
You can see I have no ZVS or nothing around this thing.
Yeah.
So I'm skipping through a little bit. I just want to show you this. It's amplifying every time I touch it. It's
With
not,
your hand?
but I don't think this system gets to perfect. That this is the closest I've ever come to getting this thing right. It amplifies on both sides.
So you're providing the exact capacitance to help this resonance increase in amplitude. You're increasing the voltage. you're increasing the power right there by touching it. I've not seen that before.
So
Yeah.
it doubles. Just so you know, the reading on it doubles on the power it puts in there.
It looks like that. This is the Slayer, right?
Yeah, so the thing was, I was trying to use my ZVS last time I tuned my gravity flare, right?
Mm-hmm.
And I couldn't get the button to work. And I was wondering why, because usually I get a sound that goes ding, ding, ding. You know what I mean? And I
Yeah.
know I'm hitting that center plate and it's moving a little bit.
Mm-hmm.
I couldn't get it to do it, and I was scratching my head trying to figure out why. And this was why, because I used the wrong circuit.
Mm-hmm.
So yeah, you saw basically what I saw is it amplifies when you're hitting that button, right?
So when you say hitting the button, which button are you hitting?
So it's a stall button. So let me go back to the circuit for you real quick.
Okay.
So you see that little red button on the top? I don't know that I can see it that well, but
I can see it. Yeah, on the bottom there of the cream colored case.
yeah. So there's an on and off switch, there's a dial, and then there's a button.
Yep.
So what the button actually does is it turns off the power of that power source right there. You see the 5 volts I got on it?
Right. Okay.
So it's a circuit interrupter.
Mm-hmm.
So when you turn it off, the oscillation that's going on the gravity flyer goes right into the piezo. Because the piezo is a transmitter and it's also a receiver,
Mm-hmm.
it starts putting off the frequency of the craft at that point.
Yeah.
And then when you let off the button, it goes back to the override signal, which drowns it out, right?
Okay.
So what I do is I push the button. As soon as I push in, it doubles in the amplification of the signal.
Mm-hmm.
And then I let it off, and then it kills that amplification, right?
Yeah. Now that's the button that shuts off the 5 volts, right?
Yep.
So when you shut off the 5 volts, it amplifies?
It amplifies because it's running based on the piezo itself, which is at a...
It's running at resonance when you turn off the 5 volts, and so at resonance it doubles the power. Is that what you're saying?
Yes.
Interesting.
So the whatever frequency is going on in the gravity flyer, right,
Yeah.
is what you're going to get as your amplification signal.
Right.
So this is why he was using the ZVS wasn't using the ZVS. So I was using the ZVS circuits, which doesn't do this.
No, won't. No.
So it's too strong. It just blocks it. But the because the Slayer Exciter is a self-correcting circuit,
Yep.
it allows for the amplification that I didn't realize it, Shawn.
Yeah. Yep. It's amazing that you found that, because that can be a pursuit of you doubling the power, and figuring out how to double that power might be a way to double it again, and you can maybe have some intense power source. If you can keep what am I trying to say? Replicate that'd be something worth looking into. I know that the Slayer hits perfect resonance.
Mm-hmm.
And if you add something or take away something, it doesn't matter. It's just gonna adjust because if you add capacitance to something, the transistor is gonna follow the resonant frequency of what you added it. Or you can take something away. And that's fascinating. I just don't play around with them because I fry them all day. And I tried building yours. I don't know why I can't get it working. It's so simple. That's the problem. It's too simple.
No, I think what it is people, they reverse the hot and the cold. They're so used to, the negative and the positive. They put them in backwards because they're so used to the normal way things run, and they blow the transistor right away.
Yeah.
And then they try to hook it up the other way, and they go, well, why is it not working? Well, because you already blew the transistor.
Right. Yeah.
Yeah, it happened more times. It happened to me a bunch of times before I figured out, hey, just follow the schematic and stop thinking. Just shut the brain off and just do what he says.
I do that a lot. You can ask my wife.
So one of the other things that I was checking out, Shawn, just so you know,
Okay.
And I'll send it to you, is that the capacitor. So we're building an open air capacitor, right?
Yeah. With the.
Now think of it this way. Okay, together, I pull it apart a bit, the voltage increases.
Yep.
I push it back together, you know what I mean? It's compression.
Yeah.
So now when I take the center disc and put it in there, because it moves just slightly when that piezo is hit, it's now doing this, causing it to compress and build. So it's like pulling it apart, putting an air gap in there, and then compressing the air back in it again, and then pressing another air gap and compressing it again, and doing that, right?
Yeah.
So it's literally amplifying every time that I push it until it can't.
Oh.
It's like a bend but don't break capacitor, and you saw right there the doubling in it. So it's like a huge amount of energy that goes in there when it compresses like that. So
yeah.
What is the one thing you tell me about the Slayer Exciter that I always do in the air?
That you always do?
Yeah, I'm making the air a capacitor.
Oh yeah. The coil, the copper coil on coil 2 is one plate, and then the earth is the other plate, and the air is the dielectric in between. So it's sandwiched between the earth and the copper coil. And so if you step in between the earth and the coil, you're becoming part of the circuit, and you're adding your capacitance to it. That's why on a Slayer Exciter, if you put your hand close to coil 2 and pull it away, you'll notice that it changes the frequency, because you're adding or taking away capacitance, because we're all big capacitors. And some of us are bigger capacitors than others.
Well, I'm a big capacitor then. I'm trying to change that, but it's hard, man.
I know what you're saying. I put on put on a lot of weight these past couple of years. It seems like when I turned 54, I got old. I don't know why. And so
Just hit that
yeah,
age and then boom.
now I'm 55. Where did the years go? And you're young and you're still in your 40s.
Yeah.
Young old man.
Well, I feel like I'm in my 70s. I can tell you that. But
I know what you're saying.
I was trying to dial it in, Sean, and I couldn't figure it out forever. And I feel so dumb because I'd done the test and I showed people how to do it. And then I literally didn't realize it. And here I am yesterday, like blowing up my computer, right?
Yeah.
And it's going off every 2 seconds and I just couldn't figure it out. And I guess if I just looked back at what I did instead of what I've been doing, it would have been so much easier.
Interesting.
So
I've done that a few times. I totally.
it's like an old man moment, huh?
It's a senior moment, right? I'm now allowed to have the food on the senior menu at Denny's, so that's a big achievement for me.
I'm not there yet, buddy. I'm getting
No,
there.
I know, youngin. That's what I call you, youngin. Yeah, I'm surprised I've kept my hair. I mean,
Oh, you got more than I do, that's for sure.
yeah. Oh, you've got a good head. I've always had thick hair. When I was in the Navy, I'd have friends try to pull me by my hair up. Almost could get on my feet, kind of like Absalom, how he got caught in a tree with his hair. We got some good comments here.
Yeah, put them up. What do you got?
Good conversation. Let's see. Limited State says it looks like that pancake is made from insulated wire with the wire stacked like an 8-knot, like an infinity symbol, hence him calling it a pancake, not a bifilar, since it is barely bifilar. So I guess what Limited State is saying that a bifilar usually has that 2 wires, they have that loop that goes around, and then they look at mine and it's a half-inch thick and it's 32 gauge and it's wound and it's crazy. Most of it is good though. But I guess they're saying it's barely a bifilar. Not sure what that means. Yeah,
I don't know. I don't know if he was talking about yours or negative resonance coil because he had 2 insulated wires, one on top of the other, instead of a speaker wire. Because I did Master Evo speaker wire. Yeah, I mean, I put a cap in the center, and then I wound a wine, put super glue on it, wound another one, super glue it, and then continue to do the same thing over and over until it came out, and then tied it together exactly like you said to do it.
How did it go?
Oh, we're great, perfect.
Yeah, Master Evo's. I think he's got like 10 videos on it.
That's his thing. That's his jam right there. Those flat pancake coils, man. The bifilers.
Yeah. He's. I feel like he's one of the smartest guys on YouTube, and I don't understand a word he says. He speaks perfect English. I just listen to him and go, oh, I have no idea what you're saying. He has a very complex mind. Very complex mind. Which is great. It's just I don't. It's for poor slow learners like me.
Here we go. 2 flat wires side by side, not vertical.
So I have a spool of flat wire, rectangular wire. It's 1 millimeter wide, but it's 1/10 of a millimeter thick. And so I was going to wind a bifilar with that, but I wanted to do this first one so I can learn. Yeah, poor man's build.
Yeah, I'm poor man myself. I think every inventor is all their money goes into their work.
That's right. It's so true. But we're happy, so it's It's a good buy. Ulysses is asking, yeah, it's 20 minutes ago. Sorry about that, Ulysses. Nathan, did you have much luck with the capacitation on the fly?
That's what I was just talking about with the ultrasound circuit.
Mm-hmm.
I was having trouble with it yesterday, and I put out a video today on it. And I just got to make the certain adjustments to fix it. It's completely my fault.
Okay. Sounds good. Sounds like you're going to get to it, though. Whoever shall build a cap coil slayer like the totem pole. Are you familiar with that? The totem pole with the slayer?
No? What is that?
Yeah, it's coming from Stefan Drysdale.
He said, say it again. What did he say?
Whoever shall build a cap coil slayer like the totem pole.
I'm still miffed on that one.
Yeah. So Dennis Matovich says, I finally added up and hooked AC to the ZVS and got 4-inch spikes, made the diode cable. Yep, you read that one from the last time of the show. Great job, Dennis.
Oh, by the way, Shawn, check this out. Remember Tesla uses wooden dowels in his Tesla coil down the center of it?
Mm-hmm.
Remember I was telling you about the heat and stuff when you can get that thing to push out further?
Mm-hmm.
Well, I did the multiple coils, okay? So I should probably show that real quick.
Yeah. Give a visual.
Yeah, because honestly, man, I found out why he's using that wooden dowel.
Oh, okay.
Okay, I'll pull it up right now. So that's wild in itself, right?
Oh my goodness. Yeah. Crazy.
So we'll just kind of go over the picture real quick so we can see it. I have a Tesla coil, and then I have a Tesla coil inside that Tesla coil, which is followed by I want to say it's a 1/2-inch aluminum pipe that goes all the way down. And then it's a 1/4-inch brass rod. So I don't have it at frequency, just so we all know this, but it's multiple field impingement. So it's crazy what happens to it as we hit it. Tesla coil, I got multiple field impingement. So 1 Tesla coil, 2 Tesla coils, a rod, and another rod, all spaced evenly apart. Wire goes straight from the top, so down the center. Right over here to this Tesla coil.
Wow.
Tesla coil's doing the breakout.
That's crazy.
That thing is so bright. Okay. Anyway, if you don't know what you're doing, do not try this. That's my Tesla coil. I got multiple field impingement. Okay, hold on. There's a better one.
Is that Slayer running that?
That's the ZVS.
Okay.
I thought this was it. I guess I do a lot of these things. Here we go. Right now, Tesla coil and 2 rods, all evenly spaced. But that's not the part that's going on right now. I got this hot side connected over to this Tesla coil right here. And I just want to see what kind of breakout I can get out of the top. And there's a weird phenomena going on. So let me turn it on. So there's no breakout, right?
Yeah, that's crazy.
It's a lot of hot energy in there.
And that there's no circuit on that. It's just a wire. So you know hot voltage, right? So yeah. That looks like a DC flyback energy, right? Exactly. Mm-hmm.
But there's no breakout on it before, and it doesn't spark over when the hammer's next to it. I have to put it next to it and pull it out.
Does it make any sound crackling before, or is it perfectly silent until you get the hammer?
Mm-hmm.
It's quiet.
It is. I'll rewind it and play it one more time for you.
Is this coil grounded?
The ZVS is grounded. This other coil is just one wire coming from the secondary. So I'm hopping secondaries. I'm going from the secondary of the primary driving circuit straight over to this coil right here on the bottom.
Okay. Okay.
So there's no breakout, right?
That's
It's a
so
lot of
interesting.
hot energy in there.
You can see all the white in it.
Why does it look like DC?
It's running more like a flyback transformer.
Yeah, like a
It's
pulse.
running more like a
Flyback.
flyback transformer.
Sorry. Go ahead, Shawn.
It's when the output of the flyback transformer, it's like a pulse DC, a Ripley DC, and then when you pull the sparks like that, that's what it looks like.
Yeah.
Yeah, that's not a AC Tesla coil looking signal. That's yeah. I don't know how it's doing it because you need some kind of rectification, a diode or something, to get this type of electricity, this plasma, but you don't have any of that. You just have a wire coming from one to the other. Though maybe something's acting like a diode somewhere.
So you know what the trick is to it is the multiple rods in the center.
Yeah, that makes. Do you have interarcing problems? Do you inside? What if you crank it?
Okay. If you crank this thing, you're going to get RF hot everywhere. It immediately puts out heat. Like I can't run that thing much more than 10 volts. And if you put it in frequency, it shoots out heat in one direction. So, yeah, a whole different process going on there. But the diode. So remember when I showed you the DC flyback, how it has a center core, and then they build out these little plastic filaments that go around it, and then they put the mylar around it, and they keep doing it?
Yeah.
Well, think of it that way. It's heating up the center rod so much that it pushes back to the outside like a diode, like a one-way diode back to it in order to create the extra energy to give me amps. So where normally the open core design takes away the amps and gives you voltage, it converts. In this setup, because the inside's hot, now I get hot amperage coming out of it.
Yeah, that's so interesting.
Let's go back to the Tesla in the dowel. By putting the dowel down the center, he controls the amount of amps that stay in that coil. So it's no longer converting from, you know what I mean, a lot of amps in the pulse to a very high voltage. It now lowers that threshold. So now it's keeping the amps in the circuit.
Yeah.
And it's not bringing up the voltage as much. Because remember, you got to convert one to the other, right? So that's what he's doing with the wooden dowel. So when we look at the Tesla Tower, okay, the Wardenclyffe, and you have that big piece of wood that goes down the center of it, you're changing the voltage value. We think it's a high super voltage, right? No.
Yeah.
He's got a lot of amps in there. He's got usable amperage right there.
So where does the metal rod go in the situation where the wooden dowel goes?
You put it right down the center. It's still, because it creates a different energy, and it's not coupled. So it's not connected in any way to your Tesla coil. It's independent. So it produces a radiant energy out of it. So it's completely separate energy, which is not stopping your regular oscillation of your primary driving circuit, right? The only thing it does is changing the frequency. But if you got a wooden dowel around that thing, you know what I mean? All you're doing is producing heat. So if I took my Tesla coil, my ZVS, and I just put sand in the center of it, I'm creating heat inside the sand, which gives me more amperage for the Tesla coil, which shoves my value out further without causing breakout.
Mm,
Notice how it didn't have a breakout until I pulled it, right?
right, right.
So that breakout stops because I'm adding to the center of that coil. I'm making it a regular transformer so I don't get breakout. Instead, I get more heat.
Right.
It transformers physics, man. It's awesome.
I'm still wrapping my brain around the wood. So the wood, has a hole down the center, and a metal rod goes down the center of the wood. This is in the Wardenclyffe.
Yes.
And then you're saying that it's similar to what you pulled out of that other coil with the hammer, that it's putting out that flyback, DC flyback energy. Is
So
that what you're saying?
yeah, the winding on the outside of Wardenclyffe on the bottom part. Okay, there's a bottom part right there.
Uh-huh.
All that winding is putting out that hot energy.
Mm.
That part right there will. And the wooden dowel down the center of it is actually just, it's adding more energy to it. So it's going to add heat to the whole thing and give it that amperage in there.
Yeah.
But then there's a separate rod that goes down the center that goes into the water table, which creates a radiant energy that's negative that goes into the water table, and that electrifies the water, okay, without any harmful effects to it, like the outside of the Tesla coil would. So he's literally pulling out the energy and converting it right there in it. Just right there in the winding, he's doing the conversion. It was mind-blowing when I did the experiment, because I'm trying to figure out why he's doing it, and that was it. Because you'll notice, take any Tesla coil you got, take anything that's in your room, okay? Hopefully nothing metal, unless you got gloves on, okay? Put it right down the center of that. You're going to immediately change the frequency of the Tesla coil, right?
Right. Mm-hmm.
So what do you know about frequency? When frequency goes down, there's more amperage. When frequency goes up, there's less amperage, right?
Usually, yeah, that's the rule.
That's the conversion. So now we know that by putting the wooden dowel in there as a core, you can get more amps in there, which means your radiant field increases side to side.
It's like an amplifier.
Yep.
So do you have wood down the center of the one you just showed us?
No, I had the multiple coils, which acts the same way.
Oh, you made an experiment of a miniaturized that met the intentions of the original. Yeah, that's fascinating. Have you put the O-scope all over that to see kind of what the waves are doing? Because it looks fascinating.
To be honest with you, Shawn, that goes to a different thing that I'm doing. I didn't want to show the frequencies of it. Because it's multiple field of impingement, you're getting a cashmere effect out of the center one, so it'll shoot a laser out of it when you bring the voltage up high enough and it's in resonance.
Wow.
And then it'll also start shooting out, I don't want to say that, but basically it's a thruster.
Oh, wow.
And if you ever turn the Tesla coil on its side and you cap the bottom of it and keep it capped, you get a one-way directed energy.
Okay.
So they used this in NASA. They came out with a new thruster that has rings in it. And you've seen different ones with these gas and stuff. This is all gasless. And it's just multiple field impingement in order to make thrust, okay, where I can kill off the laser portion of it and just get the energy boost. So
have you cranked it to laser? And
yes, we'll just say I have, and the effects are not something I can show on YouTube.
Oh, okay.
But once you get things in resonance, remember I tell you resonance keeps adding energy.
Yeah, right.
Remember I showed you all the sparks coming out of that Tesla coil?
Yeah, out of the second dairy that was alone with one wire.
Yeah.
Yeah, I look at the setup and I go, "Oh my goodness, it's next level." But there's a lot going on. A lot going on.
Yeah, that's what happens when you start putting multiple things in resonance, and then you know exactly where the ring is and how the ring builds out, and then you can captivate the strongest part of the ring down the center. Yeah.
Right. When I first saw it, I saw that there's a lot going on there, and I wanted to just take it apart because it looks so. I know how hard that is to do. If I were to just go run and put a coil inside of a coil, I did just catch fire. That's true. And I'd watch it just die.
I don't think people understand that, Shawn. They think, oh, well, he could do it. I could do it, right?
Try it. Try it. I mean, I kind of get the same sometimes. Oh, that's been done before. They haven't done the coils I made. No.
No, oh, nobody builds your coils. I'll tell you that right now. Nobody does. They build a single wind on the outside, and it has the same shape, but they don't. Nobody multiple winds it like an AC flyback. I've never seen it besides you.
Yeah.
Except for Ian. Ian made a cool egg. Did you see that?
It looks amazing. I have so many questions, but he's on the road. I think he has to drive where his helicopter is.
Yeah. Let me see if I can.
A certain amount of days. He said he won't make it tonight. He messaged me that he wouldn't make it.
I'm going to see if I can't pull it up real quick.
Ian Jackson makes a point. Quantum tunneling from coil through PVC insulator and into the center rod. Have you guys looked at Garrett Modal's work?
No, I haven't, to be honest with you. He has a spelling in there, Shawn?
He does. Garret. Modals. And it's about quantum tunneling through PVC. Interesting.
I might have some of that going on. I'll have to check it out. So,
yeah.
Here we go. This is Ian's egg right here.
I know. It's crazy. We've been talking about this for weeks. It's my Death Star, and he counterwound every groove. So wire runs one way in one groove, clockwise. The next it's counterclockwise, and it's a bifilar. It's so crazy.
And he said he was just barely off on the frequencies in the both.
I read his specs. They're almost identical, the top and the bottom. I mean, as close as anybody will ever get. Absolutely amazing. He's trying to. Oh my goodness, it escapes me right now, but it has to do with anti-gravity. It has to do with changing the mass, so that way it weighs less. I mean, I'm super simplifying it, but it's about it's a lot. I'll let him speak to it, but him and I have been talking about as he's been winding this beast, because he's very particular. You can't just, like what I do, willy-nilly. It's the groove's filled up, go to the next groove. Not him. The counter winding is what I think is the craziest.
Well, vortex are counterwound, so it makes perfect sense.
I'm just saying from a build standpoint, and it's that clean. Psh.
Oh, yeah. Oh, Ian's a perfectionist. He's really good at everything.
He's so good. Mm-hmm.
Yeah, Bog Irish. Sorry, I want to say Bog Irish.
Bog Irish. Mm-hmm. Yeah, he told me he's on the road, so he won't make it, but he's going to watch it later. I said, don't bother. I'm going to be boring.
I don't think so. No, this is amazing. I want to see it run. How is he going to turn it on? That's what I want to know.
Yeah.
Is he? No, hold on. Is he going to create the vortex coil primary number 1 like you do, and then do another one at the bottom? That'd be interesting.
I think that's one of his intentions. Yeah. Yeah. It's weird because that he took my sphere and he cut it into quarters, and he sent me it. If you're interested, I should ask him first, but he would say yes. But yeah, the way he then it enabled him to wind this better, and yeah, each groove is the opposite of the other groove, and it's a bifilar. Super clean. I didn't get the coil, or I'm sorry, the wire gauge. I think it's 32.
Hold on. Did you just say each groove is in opposite directions?
Yes.
Oh my God, that's hard.
One groove, yeah, because you're looking at maybe 50, 60, maybe even 100 turns of wire per groove. So,
Wow.
mhm. That's why when he shows you his stats, this is a bifilar, this is a bifilar, and then they're both counterwound. Clockwise, counterclockwise, clockwise, counterclockwise, clockwise, counterclockwise.
Wow. That's all I could say. That's it. So impressive. I don't know that I could pull that off unless I
No.
did a wire trick like you did.
Oh, the spinning discs?
Yeah, you know, you had the 2 wires going in at once when you wound it.
Yeah.
That's what I mean. I couldn't pull this off without that. That'd drive me insane with wires everywhere. I'd get them crossed and they'd be everywhere.
I'd be with you. I'd lose my mind with you. It's pretty incredible, though. So yeah, I think he's going to try to get it to oscillate. I think what he's trying to, I think when he asked me, there was something about getting it, the top and the bottom to resonate, because that's when he thinks the action is going to begin. So,
Yeah.
so it makes sense. It makes sense that if there is a resonant frequency that's the same from the top and the bottom, that's going to cause some radical magnification.
Hmm.
It's just going to do it.
So just put your pulse circuit in there.
The
Just
AC with diode?
take a frequency generator and put a duty cycle on it and pulse it and see what it does first before you go on to making anything else.
That's interesting. Yeah. Because it doesn't have to be all this power yet. You just throw a signal generator on it and see what it does. Yeah, that makes sense.
That's what I would do. I mean, put in whatever frequency makes the resonance point, check it out and see what the resonant frequency is, then hit it with the same frequency on your pulse generator and see what you get.
Right. Yeah, he asked me how to determine the resonant frequency of a bifilar because it's a pain in the rear end. So that's when I built that circuit. So it immediately gives you the bifilar's resonant frequency, because that's then key for him to get them both to resonate. Because if one's not at the same resonance as the other, then he can start taking off wire. So they're identical. So my little setup is the resonant frequency tester for the bifilar. So I'm just going to draw it out and send it to him.
Yeah, there you go.
Cool.
Yeah.
So there's Toy Maker says, Ian, you realize that QM and the ether are 2 totally different, incompatible theories. Esoteric Gold says, is that a time machine? I want to try it. Take me back to when Bitcoin was first developed.
Oh,
yeah.
buy as much as you can, huh?
Yep.
Huh.
Let's see. Esoteric, laugh out loud. I bet that was a fun build. Ulysses. Q10 says, and you'd really just have to send the information, Tommy guy, in a sine wave, not a square wave. Actually, it sounds like a perfect test. I think they're referring to testing that Ian's device. That makes
Yeah, sounds like it.
yeah, cool. Wow. So what was I gonna say? I wanted to find I won't have time to find it here. I have such a mess. So what's the big thing you're working on now for your monthly videos?
Well, we ran across the frequency of aluminum. We ran across the capacitor. I have a way to pulse the capacitor on my gravity flyer.
Uh-huh.
I put everything aside to push this thing to the limit. So it comes down to this. I learned from my Tesla coil resonance.
Mhm.
Okay. Once I create resonance between two things, I get an amplification of energy all day long, right?
Yeah, right.
If I can resonate the aluminum in the center plate, the upper plate, and the lower plate all at the same time, I'm going to get a monster number out of it. Okay.
Yeah, that's tough though. I mean, that's exactly what's going to happen.
So now I have to put my Slayer exciter circuit in and allow the piezo to pick up the signal of all of it, right?
Mhm.
And then be able to cut it and then amplify it. So, man, it's like doors opened and you finally see the light coming through.
Right.
And you're going, okay, I have a window, a doorway open for me right to the answer. Every test that I've done, every bit of data I've accumulated leads to this moment. It's like, I know where the capacitance is built. I know exactly how giant the field is. I know, how much energy is in there. And trust me, it's over 1 million volts. It gets in there, not amps, but volts, pure voltage.
Right.
And it's built up in a monster field. And this thing gets to 25 kilohertz. Okay. Or excuse me, megahertz. 25 megahertz.
That's low. Okay.
It's way above the kilohertz level. It's going to really push this thing through the roof. So I want to see it hit one leg. I want to see it hit two legs, and then I want to see it take off. So I finally found exactly what I needed. And I'm going to give it 30 days and push this thing. And then I'll go back to my other projects. But this is something that has been on me for a year, and I want to get it reverse engineered.
I mean, how close do you feel like you're going to realize this? How close do you feel that you're to this? Because that's something I've always had in my head. If I can just get everything at the same resonant frequency, the objects, the coils, the metal, because every object in the universe has a resonant frequency.
Mm-hmm.
I really believe if everything's in resonance, it's going to tear a hole in the ether. I don't know. I mean, it's going to swirl ether around you and push you up. Is it going to explode?
I don't think so. It's acting okay. So the Tesla coil field's holding in the static electricity, just like a plasmoid.
Mm-hmm.
Okay, and it's separating itself from the gravitational field that we're in, the saturation field.
Mm-hmm.
It's literally separating itself. So what I'm building is the lift factor for it, the way that it has to lift in scalar. So it goes to how much energy I picked up as soon as I put in the frequency.
Mm-hmm.
So before when I did it, I had to tap the center plate, right?
Mm-hmm.
Physically go over and hit it in order to get this frequency, this amount of energy to pick up. Okay. Mm-hmm. And now I can get it immediately. I have more than what I had before, and I have it immediately, and I have zero sparking going on. There's no sparking whatsoever going on those two wires coming down.
Mhm.
As a matter of fact, they're off of each other by a 1/4 inch. So it's just literally pouring energy onto those discs, right?
Yeah.
So the capacitor is built. It's, you know what I mean? It's stable. The only thing I have is I was setting the wrong frequency on one of the other parts where it pushed too fast, too far. So instead of building plasma in between them, I was
Mhm.
blowing it out. And that's
Mhm.
when my computer was going off a lot, right?
Yeah, yeah.
Now I can stop that because now I can dial it in on that ultrasound.
That circuit that you were sharing, right? Wow.
That's the key to dialing that in. So it stops that and it starts building capacitance inside of it. So
Nice.
you think about it this way. If it's not letting it pass that field, I am literally putting energy into it every second, like a fire hose. So what happens to all that energy if it doesn't push past that field?
Yeah, I don't know.
Well, it keeps filling up. I'm like pouring it in. It's like a big bucket that I keep filling and keep filling and I keep filling and I keep filling it, and it's not full.
Mm,
So what happens when you start pulsing something like that in pure energy inside of a bubble, but it doesn't break the bubble?
I don't know.
That's
Does it distort space time and bend gravity? And I mean,
oh,
what is
you get time dilation as soon as you start creating sparks, and you start doing it with high amperage going on in a field. You'll start getting some time dilation, time distortions going on in your garage. But this is
wow?
kind of different. This is more of I'm building an open air capacitor that can store a bunch of voltage, and it's a bend not break. I'm breaking it and I'm breaking it and I keep breaking it.
Man,
Now I have a way to keep it in.
that's key because that's a tuned system to keep it in. Everything has to be right. It's like building a dam. You don't build it exactly right. It'll show you where you messed up,
Mm-hmm.
and it won't be fun. Interesting. Good stuff. I
Yeah.
found my instructions, so we're going to be good for next week. Um, as I'm starting to fade here, I'm having such a blast. And guys, in the chat, I love you. I only have 5 more minutes, if that's okay.
Yeah, we're good. I know. I understand you got a timeline.
There's some questions for you, Nathan. Ian Jackson, Nathan, the video on wireless transfer in a room, same people have an auto tune system that keeps coils picking up in many orientations. They also found out they could pump 1.5 kilowatts without exceeding SAR, SAR. Not sure what that is.
Interesting.
Yeah. Magneto says, which is resonance, harmonics. Resonance, you're good. If it sounds good, it's good.
So it's all based on the geometry of the resonance. And
Yes. Yeah.
so it's fractal geometry, which basically just means it's fractions. So
Right.
we were looking at Bob Greenyer, and he had this shape, and I can't even describe the shape. Anyway, it was a tornado that built out in sevens. So it'd be 1 7, 2 7, 3 7s, 4 7s, but it actually makes a vortex when you build it, and it's a geometry based on a coil. So if you take it in a geometry coil, create 24 pins, and wrap this right here, you're going to get sevenths and harmonics building up throughout that in a vortex. So if you can understand that, then you can understand any geometry coil based on how you build them. Is it in the sevens? Is it in the eighths? Is it in the thirds? You know what I mean? And you'll be able to put the vortex into it based on the multiple geometries that you do,
Yeah.
you can pull off any kind of resonance you want because it ultimately is what's building your ring, right?
Mhm.
So that ring that we usually see go like this, it's a vortex, man. And it's built out.
Yeah, it's three-dimensional.
It's built out in
can't see
fractions.
that. People can't see that they're circles. You showed me that.
Mm-hmm.
Yeah.
Oh, huh. Let me show the video real quick, if you don't mind, Shawn. If you got it won't take but a second.
Sure.
I just want to show this because it's insane, isn't it?
Yeah,
That's what it should look like on your oscilloscope all the time.
is having that vortex.
Mm-hmm.
Vortexes.
Instead, we see it as a ring.
I mean, it is a ring, but it's looking in that three-dimensional. That's hard to see. It's two tornadoes on their side.
Mm-hmm.
Right.
I mean, when you create the ring, that's literally what you're creating. You just can't see it right because the oscilloscope doesn't show it right.
But this animation looks like it's three-dimensional. It's a clever way to imagine it.
Yes.
So yeah, so kudos to the guy who sent that to you, or is it yours?
Not mine. I'm going to have to ask the guy exactly how it's done because you know me, we got to reproduce just about everything.
Yes. Or Ian. You and Ian.
Yeah, well, you know what? You don't learn until you do it, right?
Oh yeah. I agree. Magneto makes a point. Make some pan drums and learn how to tune them, size and shape, and in harmony. Then you know how to make the discs perfecto.
Make them perfect, yeah. I think one of the things is going to be is I'm going to get your little pulse circuit, if you don't mind, and I'm just going to run it on that disc and find out where the frequency is of it. If you're telling me that's what it could do, so let's check it on that. And I have a bifilar. I can run that pulse right into that bifilar and just set a disc right on top of it, just like the guy did with his wine bottles. And we'll just see where the ring is. We'll just find out if it has anything in it.
Yeah.
Because the more information we get on this, the easier it's going to get. I mean, people get on me about things shaking. You know, this thing is built so poorly, Shawn. Like, I followed the original inventor's device, right?
Okay.
I usually build things, you know me, I build things museum quality. I like them perfect. And
Oh, I know.
it's out of sorts for me. So then the thing, man, is literally magnets on the bottom with centrifugal force that causes this thing to shake like crazy. And unless I rebuild the entire thing with parts that I would prefer,
Yeah.
it's going to do that. And then it gets worse when you put resonance in it because then it starts to vibrate like crazy. And
Yeah.
it drives you absolutely nutty if you try to take all that out of there. And it probably ruined the whole invention that he made.
So you're learning the concepts. You're taking the concepts from Alexi, and you're saying you're on a track. You create a track for me to follow, but there's more to this than what he's sharing. And since you've been so close to building this thing, you figured it out because you've tested it in every different way.
We built every single part of it and tested every part of it down to the smallest detail to pulling the energy out of the Tesla coil, to find out what the motors do, to find out what the eddy current does, to find out what the piezo does in every single circuit that he uses and why. And it was just the last little piece because I'm going to be honest with you, Shawn, everything checks out. Does it make a field bubble? Yes. Does it hold in static electricity? Yes. If you put the static electricity in the opposite configuration, will it push it out? Yes.
Wow.
So it literally makes the plasmoid field when you're building it. And I think a lot of people miss that. They just blow it off like, oh, I could do that. No, you can't. You better know it, because it should change the energy from the Tesla coil to a radiant energy, and it builds out to hold in that energy. And every time I check something on it, it passes a test. And I'm going, you got to be kidding me. There's no way he knows this much about physics in his garage and this thing not work. I just, it doesn't happen that way. You know what I mean?
No.
So that's why I want to see it through to the end. And for one way or the other, okay, and I'll just say this, for one way or the other, I'm going to find out. So either I walk away from it with the understanding of a Tesla coil and field physics,
Yeah.
or I walk away with anti-gravity. Those, I already have the two. I'm waiting for the one. You know what I mean? It's kind of push my chips into the table and let's find out.
Yeah. I've always said if it's there, you'll find it. You're just interconnected, and you have an instinct for it. So I was telling my wife, I think I should be called the accidental inventor, because sometimes we're just plowing through every different permutation of what we want to do, and all of a sudden we learn so much, and then we get intimate with the details to where we know now. And
Mhm.
it seems like you're at that place right now where you're just, okay, I know how each piece is supposed to go because I've learned so much. And you can see it. That Tesla coil within a Tesla coil, I immediately said, there's no way in heck I'm building that thing. I want to build it. Because see, the thing is, oh, I'm just going to go wind it, put it in there. Okay, good luck. Because as you stick the rod in, it's going to all try to burn up the rod inside, because you're inner arcing, or you're not going to get it to resonate at all, or you're going to fry your transistor every time you blink, or, I mean, there's so many things that are into that. So I look at it and go, wow, too much. That's your area that you're great in. I'll stay in my area and we'll come together, right? We'll come together.
I want to answer this question right here.
Yeah.
So how did I need to get the old man when I'm in my 40s? So I'll just say this so we all know. When I was in my early 20s, probably about 21 years old, I broke one side of my back. And down at the bottom, L5S1, I snapped one side.
Oh, no.
So I worked for 6 months. I snapped the other side of the same level. And then probably 6 months after that, I found myself in the parking lot sitting, laying down next to my side loading semi truck. And I couldn't walk, couldn't feel my legs. So when I regained movement in them, I went and, went through the process and everything, and they repaired it.
Yeah.
The problem is nothing ever works right after that. So all the, muscles around it never worked right again.
Oh, wow.
And then I went back to work, which made it even worse. So you can imagine 16 pallets of soda all day, taking them down, uncomfortable positions and everything else, going through that for the next year. My body was blown out. So I walk like I'm 70, and I can't do sit-ups or stuff like that. You know what I mean?
Oh, yeah.
I'm physically shot. And that's why I get the name Old Man, because my kids always laugh, and they used to call me caveman when I was younger, right? Because I have crazy long hair and everything. And then now they call me the old man because now I can barely move, and I make all the grunting sounds when I get up. So it's not that I'm physically old. It's my body's physically destroyed. So that's why they call me the old man.
And you have other challenges. You're just laying out a few.
Oh, it's just the basic one, yeah.
And the thing is that no one would have guessed, because you're always lively, full of energy, positive. And so kudos to you, man. I'm serious. It says a lot. It's an example for people to aspire to. If you have all these health problems and that yet you do these amazing experiments, you youngins, like Simple Man 911 says, I'm almost 23. You youngins,
Yeah.
my oldest daughter turns 30 this year. That's crazy. That's a good example, Nathan, and I appreciate you sharing. Um, it's you've got some mileage on yourself.
Yeah.
My miles. I
Yeah.
bet I can beat you though. I have more diagnoses than you do.
Oh, yeah, you got me, Shawn. I could sit up here and be happy. You have a lot more going on than I do. That's for sure.
I mean, I don't know. I appreciate the kindness. That was a joke, I hope, but yeah. Oh, someone's 55. Yay, I'm 55 with you. Michael Merrick, 43. Magneto, 33.
Nice.
Harry Kevlar, 36. This is fun. Counting the ages. Genetic Jabber, 34.
Nice. Dennis
Matt,
has got 57.
wow, 57. You beat me. This is a game. The highest score wins.
I get 48 this month.
48. Wow. I remember when I was 48. I retired when I was 46. So,
Oh, Ian Jackson's got 59.
wow, you're almost on the 6-0. Now
Nice.
that's old. 55 is young, but 60, that's
Oh,
old.
there's only a couple of years difference, Shawn. Don't go there.
I'm kidding. It's,
I hope we all live to our 90s. You know what I mean? Or beyond. There we go. Electrostatic Gold's got 51.
wow, so there's only a couple snot-nosed kids. Pretty much all of us are in,
Oh
these
my God. You really are old saying that.
yeah, I beat almost everybody here. Oh my goodness, Magneto.
Oh,
Straight dope. Straight
I
dope. How
remember
old
that when
is
I was
dope?
that young.
I bet you dope's 30.
I think Dope's a little older than that. He's in his 30s, I bet, though. There we
Huh.
go. Jaso's got 45.
Wow.
Oh, he's got
Dope is
39.
I was 9 years off. He had that baby face going on. I'm still chasing teens for butt kickings.
Oh, it's so funny the stories you get when you get old, huh? You literally are offended by everything when people come by. It's like,
Yeah.
what are you doing in my yard? Why are you here? What's going on?
Yeah.
Oh, Darren's got 58.
Stefan is 56, but feels 36. Yeah.
Oh, I wish I felt 36 again.
I don't recognize that guy in the mirror I see every morning. I don't know who he is. As my eyesight gets worse, the better looking I get. I've noticed that.
Oh, man. When I was in my 20s, man, I was couldn't break 220 pounds to save my life, man. I
What's your
was
height?
super skinny, man.
What was your height?
What's that?
How tall are you?
6'1".
Oh, okay. I was 6 foot when I joined the Navy. I was 5 foot 11 and a half when I got out. Yeah, from my back injury.
That'll do it.
Bummer. I missed that inch. I want to be 6 foot again.
We all need an extra inch.
Oh my goodness. The junior high bathroom humor is coming.
To get the old man started.
Yeah, 6 says, since you also work with frequency and vibration, do you take it into account the difference between them, like in music? Like like a major second, major third, minor, or perfect intervals.
Yes.
You know, there's such an intermingling I've noticed with music and sound and vibration and it has to do with harmonics and notes and major. It's almost as if nature is a symphony, and we are conductors. And if we can, I guess, write the correct symphony, then we'll achieve amazing things. I guess incredible things.
So let me say it this way: if I can take a tuning fork and turn on another tuning fork, right? I get a ring to do it. So we know that that's resonance. But if I could take that same tuning fork and turn on a guitar string, we know that as your scales and A and harmonics, right? Or B or C or whatever it is, right? Is it that different? So when we look at it, you're doing the exact same thing. You're taking frequency in order to create vibration in the string at its resonance frequency. So it does build in every scale of the harmonic scale. And it does it in the exact same way harmonics does. So normally we'd say things double. Well, that's not exactly true now, is it? You can't multiply it by 2 or double it. It seems that way. But in the scale of A, it's 55. You take 55 plus 55, which is 110, plus 55, which is 165, right? That's not doubling. It looks like doubling, but it's close, but it's not. But it's just a scale of A as it builds. So that's what's building your harmonic ring, and that's the resonance ring. It's all harmonics. See, that's the missing link right there. If you can just start thinking about it as a tuning fork tuning on a guitar string and making it vibrate with harmonics, then you're set. That's the link. That's all you need to know. And the whole world starts opening up and you start understanding, okay, so just like in A, if I put it in a half wave to my full wave, it still resonates. If I put it in a quarter wave to my full wave, it still resonates. So and Don Smith does this beautifully, and he creates a coil. Then he uses quarter, halves, and 3/4 waves in order to pull off multiple resonance frequencies, which they all ring together, which all produce an extra amount of plasma inside of them, which gives them energy. And then he pushes them together to get that hot energy out, just like I showed you in that experiment, in order to get to over unity. It's a beautiful sequence of events if you understand it.
My when it sounds amazing, but whenever I hear about music, it requires an atmosphere. It requires air.
Yes.
But if we're looking to build a craft, let's say, to leave places that have no air, basically be in places that have no air, what are the vibrations going to be? The matter itself? There's no air to vibrate, so there'll be no sound.
In where now? In space?
Because a lot of what you're saying only occurs with an atmosphere. There's no sound in space.
Not necessarily. That's where the scalar portion comes in. Frequency at a difference in temperature. Remember the rings around the planet? Each one builds out and then the field drops off. It mimics your testicle, right? And then it stops and then another one starts up. But in a planet, the same as the sun, you have an atmosphere in there. So it's ringing in that atmosphere. Even Mars has an atmosphere. It's just pushed into the planet, right? So where it rings at, it still has it. You see what I'm saying? So if it doesn't have an atmosphere like the moon, it's not going to ring. And that's where you start getting different fields, different planets, different things. They all have different ring values. Now you understand scalar a little better. Boom, that's exactly how it builds out. We're looking more at it in air as sound is movement. So just like the tuning forks in the boxes,
Yeah.
the boxes create a chamber for the sound to build in and shoot to the next box. That's what it's doing. But put two tuning forks right there without the box, it's hard to turn them on together because
Right.
there's no movement. It's only the movement in the air right where they are. So next to it, it's good. At a distance, it's not. Put the box in, now you have sound that moves the frequency. So,
Take the air, there's no sound.
right.
So what's vibrating in space if there's no
Well,
sound?
that means there's less of it, isn't there? But there's less. The viscosity is less altogether in space. It doesn't have to work as hard in space as it does in the air.
Well, what are these?
Because there's still air in space, there's still water in space. There's just not much of it. So
yeah.
you still have a field energy in space.
But there's not enough to vibrate. And so I'm always curious at these theories. They sound very good, but then when I try to take them into space, they seem to fall apart. Unless it's completely associated with the vibrations of matter and objects, and they're the objects. The vibration of their atoms is what are the fifths and the harmonics and they build upon each other with the resonant frequencies.
What
the atmosphere?
What if I just told you that it's the atmosphere on each planet itself which gives it the ability to pick up the frequency of the sun itself? It's because it flips the fields inside the planets as hot energy, it could pick up the actual frequency of the sun.
I mean, that sounds plausible. I mean, it's a very, very interesting theory. When you first said it, I go, whoa, yeah, that kind of makes sense. It's fascinating to think about, at least. Yeah, fascinating. A lot of people are going wild in the chat here.
Yeah, well, everybody has a way of seeing it. They see it as light. They see it as magnetism. It all kind of blends together as you build it. The more magnetic fields you have and energy, the light changes the color.
Right.
All the way till it gets to the point where you can't see it, but the plasma is still present. It's based on light's based on how much magnetic fields in it to create the light. It's like a filter, or I should say it's like I don't know how to say it. The frequency and the magnetism create the light, so you can exactly figure out the frequency of the light.
Isn't the frequency the light?
Yeah, well, that's the thing. That's what they see. They keep saying that's a whole different like particle or something, and I don't know that it is, but they keep saying it is.
It's always hard for me to imagine that radio is a light wave, radio waves, and the gigahertz in our microwave is light, and so all of these are light, but we just can't see them except for the color range. Because so that's always been hard to wrap my brain around, because I'm always thinking there's photons, but there's only photons at certain frequencies. Not every frequency creates photons.
Well, I could tell you the light spectrum, I can do it in my garage. I could do it with high voltage very easily. And I've gone through, as a matter of fact, I did an experiment a while back. I got every light in the spectrum just about. And it was because I blew the thing up and created a misguided adventure with high voltage, and it went through the rainbow. Let me just tell you that before it started on fire, it went through the rainbow.
That's awesome. I've seen a little bit of that, where things go awry, and I go, "Oh, colors! No, it's smoke." Yeah.
I mean, I'll leave that up to everybody else, the light thing. I don't get involved in that more than what I can say about the high voltage and how I created it and can see it.
Yeah.
That's a whole level of physics I don't get into. I stick with the resonance portion where I'm good at it.
I just stick with plasma. I'm excited about plasma, and the way you manipulate plasma is out of this world crazy because the way you transform it to different, you make it for your purposes, and that's incredible, incredible. The way you store it, and then you come by with a hammer, and it just comes out hot, but it has no temperature until you get the hammer out. That's so crazy.
Yeah, I should start running that temperature camera on there and see what I'm getting, because I bet it'd tell you a whole lot about what's going on.
I bet you it's cool until you get the hammer. I bet you it is. And then the hammer, I bet you is so hot you won't even register. It'll be like looking at the sun.
Yeah. Oh, you know what? Now that I got that thermal cam, I'm running my bifilar. I want to see if there's any fields on it that I can find them.
Oh my goodness, yes.
I never thought about that. I should do that tomorrow.
I have a tip when I use my infrared camera is until I get it tuned, it burns out one of the MOSFETs.
Mm-hmm.
But not if I have my infrared. I'll have my infrared, and what happens is when you're out of resonance, it just overheats not asymmetrically. It'll burn up one side or the other. It doesn't just burn everything evenly. And so when I get it tuned, though, then I don't have to worry about temperature at all. And that's what's fascinating about getting things in resonance, is that it's a state where everything's balanced. It's a balanced system.
Oh yeah.
It's a no ripples in the pond. It's a low disturbance. It's more of a gentle thing than it is a hard thing.
Mm-hmm.
Hammer. And you think, oh, I'm going to crank in more power and get more results, and it's more kind of like judo.
It's the opposite, isn't it? I don't know if you've noticed this. When I crank up the power, it causes it to compress inside there, and then it creates heat, and it ruins the effect of the resonance. But then when I keep it at a light resonance and it flows real fast, I get the most beautiful signal in the world, and the energy is abundant.
Yeah, that's exactly right. That heating coil that I put in that big pot, and it was 9 volts AC, and it heated the whole thing at 350 degrees. I'm not saying that I did anything special, but it always surprises me how we have expectations that things are going to use a lot of power, but they don't use as much power. And I'm wondering if we don't design systems to use a lot of power because we don't know better, or just our what's the word? Our technology is narrow in its thinking. Because it surprised me that heating element should have taken a lot of volts and amps. No, it turned red hot, and you saw it on the video in 20 seconds. It's yeah. Oh, attraction, contraction, refraction. Oh yeah. Oh yeah.
Well, I think when they say they put these things more efficient, they put them closer to resonance frequency when they make these transformers. So they become more efficient, so they don't take as much energy to use, right?
Yeah.
So it makes all the sense in the world why they're doing it and what they're doing. They just don't tell the public that. There's devices that are over Unity on their label as soon as you see them.
Wow. Magneto says, there have been different tuning systems over time. We are used to what we listen to. It sounds good, but that's a lot to do with familiarity. The voice of creation is a wide spectrum sound. Nathan, do you have a laser pen?
No. Oh, here's one for you, okay? Get Norman Wooten into this group. He's got a motor for Floyd Sweet's car. I'll contact him because that's interesting.
Yeah, that's the water car, right?
No, Floyd Sweet. That's different altogether. That's over Unity at Residence and Cold Energy, if I'm not mistaken.
I'm writing it down. I cannot keep up with these fringe scientists.
Oh, they got it all. I can tell you that. You could ask them anything. The chat's really good and smart, man.
Yeah, we got so much brain power here in the chat. Let's see.
I do have a laser cat toy. If you want me to put it in there to see if the field formed and then see if it reflects the light, I can see if I could do that. That'd be an interesting one. I think that's what they're looking for.
Yeah, that'd be interesting. Do you remember that short video I sent you, I think last week, where the guy was able to feel the resonance from the aluminum disc?
Yeah, I was showing that on my channel as well. Yes.
Oh, yeah. I want to get there. I want to be able to do that. And that made me think of the gravel flyer. You should be able to feel the gravel flyer.
Oh, I do.
Yeah, not blow you down or not loud vibrations, but just that field.
Okay, there's literally a 2-foot field. Wear shorts next to it, and all the hairs on your legs stand up. It is powerful.
That's my goal for electorates. Wow. I didn't know that, though.
Well, not a lot of people know that. I don't usually talk about it. I tell people it fills the room because eventually it will, and you have to shut down everything for the day. So that's when you start getting really weird stuff start happening, when you start filling up your room.
Makes sense.
Because you're literally using the grounding from your wall plug, right? So every wire that runs in your wall has a ground. Well, now you just created a field in the room of grounding. Yeah. So let's just say it's not fun to do.
The ground's not really helping. Everything's getting charged. I've seen that in part, but not to your level yet. I've seen that though.
Well, it's like when you put one Tesla coil to another, right? Separate them, but keep the same grounding wire in. What happened? The frequency of this one will touch the frequency of this one all the time.
Yeah.
You'll get that faint signal no matter what, pushing back through the ground. That's why the ground in your house is a dirty signal, because it does that all day long, usually at 60 hertz, but you're putting an override signal through that wire over to the other one, so now it lights up. So now, say 20 feet, not a problem, as long as it goes to the ground.
Yeah.
So it should teach you something about what your ground's doing, you know what I mean, everywhere else. We're literally creating a field above us and below us in that 60 hertz frequency that we have to push out of our way in order to get somewhere. So
interesting.
We literally have a field above us and below us because of all the energy going on.
Wow.
So,
yeah.
But I think people take that into consideration. So if you're in a city, doing an invention like the gravity flyer is bad. You got to get out, to where I am in the boonies. You know what I mean? The bad side of town where there's a bunch of empty lots. Mm-hmm. So the amount's less. That's why you probably see Alexi out in the woods all the time, because he doesn't have that hanging over his head. He's not pulled down by it.
Interesting. Do you think we can sense that pulling down?
I think some people can. Some people are sensitive to this stuff.
Yeah, because I know that when I go up to our little lake cottage, it's so far out in the middle of nowhere. We have bald eagle's nest. We have beavers, 50-year-old snapping turtles that come out of our lake, lay their eggs in the forest, and then go back into the lake. 50 to 75-year-old turtles. I can go on all day. Cougars, bears. I had a 550-pound black bear stroll through my backyard, and I'll tell you what, that'll sober you up real quick. I mean, it's hilarious because you go to the website at the state DNR and they say, "Oh, black bears don't attack and they're friendly. Don't worry about them. Just don't touch them." And then I talk to the locals and they all have these stories of bears attacking.
Oh,
One bear looked at a guy and then the guy started wanting to take off. The bear ran over him like a truck. And as he ran over him, he striped him.
oh,
He peed from foot to head, covered him in bear pee.
oh.
Yeah. And so I when I hear the local stories, I'm like, no thanks. When I see a bear, I'm not going to go, oh, look at the bear. I'm going to get out of there. But to my point, I guess, is that the air is just different. Everything's different. You just feel it. No power lines, no nothing.
Oh yeah, you got the calming sounds of nature that are not out of balance. It's like listening to 432 instead of 440. There's no distortion in 432 where there is in 440. It's so much different. Yeah, all the see. I'm mostly deaf, so I don't hear a lot of that noise that you guys hear. So I don't get it. My ears don't put it in. I'm 80% deaf, so it literally I don't hear any of that.
Do you have a hearing aid or do you just
I do.
enjoy?
I don't like to wear them because then I get to hear everything you guys hear. So my wife does dishes. It sounds like she does them with a jackhammer.
Oh, because it's sensitive. Wow.
Yeah.
So I've gone a little longer this time. That's awesome.
Well, you have. So I know you got to get running, Shawn. Dude, it's been so cool today. Just hanging out and talking and answering questions and showing different stuff. We'll have to do it again.
I had a blast, and I'm kind of surprised. A lot of people were hanging out with us. We just dropped 10 people, so that was interesting.
Yeah, well, we're on X now, so you can tell your wife that you're on X. And we're also on YouTube. So,
wow.
You're picking up Rumble. So, yeah, a lot of people came in and chat with us and hung out with us, man. So,
yeah, I appreciate all the good information, guys, and the good questions. It's just great. Thank you guys for hanging out with us and having this experience. I'll have a whole lot more stuff to show in next week. Some how-tos. And then I'm really going to get that plasma out of that pyramid if it kills me. I want that thing singing. And I bet there's a lot of secrets in that.
Oh, I know there is.
I believe it. I believe that geometry is kind of special.
All right, guys, before we get out of here, I just want to let you guys know every Wednesday or mostly every Wednesday when Shawn's up to it, he comes in and hangs out with us for all the new people out there. Always talks about his Tesla coils and what's going on. We also do live shows on Mondays and Fridays as well. Joe's hanging out with me on Fridays now instead of Saturday. So I get the weekend off, which is nice for me. And then I offer membership to the channel, guys. If you guys ever want to get in on that, you can see some things early. I add some extra things on there. After the show's over, I'm going to add a circuit on there that you can use to change the frequency of your DC flyback. That would be cool.
Nice, yeah.
People love to hear about that kind of stuff. I love being able to control everything.
Yeah, I can't wait. That's awesome.
Yeah, I have a Patreon if you guys ever want to help me out so I can get some stuff built too. So it's all in the description of the video here. So with all that said, Shawn, I think that's it for today.
If I could just say, hey guys, be sure to like and subscribe if you enjoyed the content. Helps a lot with the algorithm. Also, commenting is great. And again, I appreciate all of you guys, and I look forward to seeing you guys next week.
Right on, guys. All right, here we go. We're going to add this, and we're going to pull out, Shawn.
All right, awesome.
The old man, real man, real man. The old man, real man, real man. The old old man builds. The old man builds.
The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds.
The old man builds.
Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend.
The old man builds. The old man builds. The old man builds. The old man builds.
Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend.
The old man builds. The old man builds. The old man builds. The old man builds.
Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend.
The old man builds.